Assalamualaikum. Our group will present Thermofluid Assignment 2.
We will conduct an upside-down glass experiment. The materials are a large container, a plastic cup and water, and a corrugated cardboard. First of all, prepare all the materials to conduct the experiment. Begin by filling the empty plastic cup with water. Next, gently place the cardboard on the top of the plastic cup. Gently place your hand on the cardboard, then flip the plastic cup over. Remove your hand slowly from the bottom and watch the cup as the cardboard stays covering the cup and the water doesn't spill out.
For question number 1, we are doing an upside down plastic cup experiment. The explanation for the experiment is when the cup is turned upside down for the first time, the pressure within the cup and outside the cup are equal. However, if you look closely, you can see a small amount of water leak out between the card and the cupboard. Why doesn't the water spill out of the cup with corrugated plastic cardboard? Any object in air subject to pressure from air molecule colliding with it. This air pressure is pushing up on the cardboard from below while the water is pushing down on the cardboard from above. The force on the card is just the pressure times the area of which the pressure is applied. The force from the air below exactly contracts the force from the water above and the cardboard stays in place. There is several things happen at once as the air expands to fill the increasing volume. The air molecules spread out so that fewer of them collide with the container's edges each second and they slow down so that they don't collide as hard. According to Boyle's law, absolute pressure and volume of a given mass combined gas are inversely proportional provided the temperature remains unchanged within closed system, and as a result, the air pressure will drop slightly. The downward pressure inside the plastic cup is now less than the upward pressure outside the plastic cup, and this pressure difference is sufficient enough to counterbalance the gravitational force pulling down on the water. Everything will stay in place after the cardboard stacks enough. And all of this is possible because the water creates an airtight seal between the rim of the cup and the card.
Next, calculation. First, we measure the height of plastic card equal to 15 centimeter, and we measure the diameter of the card, and we assume volume of water equal 100 milliliter, and we calculate the change of water, and we get 148.5 milliliter. This is new volume of water. Next, we calculate the change in air pressure, which is P1 is pressure of atmosphere, and V1 we get 1.5 multiply 10 to power -4 meter cube, and then we calculate the pressure 2, which is the equation P2 equal P1 V1 multiply with 2, and we get 100.32 kilopascal. Next, we calculate the pressure hydrostatic. We use the equation pH equal rho GH, and we get 1471.1 Pascal, and then we can calculate the force inside, and we get 2878.09 kilonewton. And also we can get force outside equal to P atmosphere multiplied to area, and we get this. And then we can conclude force outside greater than force inside. That's all.
For question number 2, the real-life example of fluid mechanics that we choose is airplane's wing. Bernoulli principle eventually became the basic for the airfoil, which is the end-to-end design of an airplane's wing. An airfoil is shaped like an asymmetrical teardrop, turned sideways with the fat end towards the airfloor. The airstream divided as it hits the front of the airfoil, with part of it traveling over the wing and part passing beneath. However, the airfoil upper surface is curved, while lower surface is much straighter. There is two different theories to explain the airplane wings. The first one is Bernoulli's principle. In fluid mechanics, Bernoulli principle states that an increase in the speed of a fluid occurs simultaneously with a decrease in pressure or a decrease in the fluid potential energy. The second one is Newton's third law. Newton's third law states that when two bodies interact, they apply force to one another that are equal in magnitude and opposite in direction.
Example application of Bernoulli principle is airplane wing. Airplane is an air transportation. Airplane is a fixed-wing aircraft that is propelled forward by thrust from a jet engine. Airplanes come in a variety of size, shape, and wing configurations. This diagram shows the part and function of airplane, but we focus part and function of airplane wing. Function of wing is generate most of the lift to hold the plane in the air. Next to wing engines to generate thrust. Third, slats to increase lift. Spoiler to change lift drag and roll, and aileron to change roll. Four main force on an airplane, which is lift, weight, thrust, and drag. First, weight is a force that is directed toward the center of the earth. Lift is generated by the wind and forward motion of the airplane. Third, thrust is generated by the engine on the airplane, and drag is resistance and a craft experience when moving forward through the air. Airplane wing has an airfoil. Function of airfoil is a surface designed to obtain lift from the air through which it moves. How do we have airplanes fly? Airplanes are unable to lift into the air and stay there because of the shape of their wings. How lift is created? Air flowing over the wings upper surface accelerates as it passes through the constricted area. The airflow over the wings at an increased speed and therefore at the reduced pressure compared with the surrounding atmosphere. Therefore, the resultant pressure difference between the air above and below the wing tends to lift it up, and the result is a decrease in pressure on the upper surface of the wing. The result is the phenomena known as lift. This is referred to Bernoulli principle.
How airplane take off and climb. First, the speed of the airplane is increased by increasing the thrust of the engines. When the airplane's speed is high enough, the pilots activate the flaps and slats. Lift is further increased. When the airplane is ready to take off, they activate the elevators upwards. The tail force tilts the airplane and the angle of attack of the airfoil will be increased. The lift is increased and the airplane takes off. An angle of airfoil attack of 15 degrees is maintained for the takeoff. When the airplane reaches level flight, there won't be any acceleration or change in altitude. We can see that with this condition, the thrust should be exactly equal to the drag and the lift should be exactly equal to the weight of the airplane. This based on the Newton's third law. How airplane landing. Landing is the last part of a flight where the aircraft returns to the ground. To land, the airspeed and the rate of descent are reduced to where the object descends at a slow enough rate to allow for a gentle touchdown. Landing is accomplished by slowing down and descending to the runway. This speed reduction is accomplished by reducing thrust and or inducing a greater amount of drag using flaps, landing gear or speed brakes. Thank you.